Welcome to Duality Check, the podcast where two brothers embark on a thrilling journey through the realms of scientific inquiry, the enigmatic mysteries of the past, and the uncharted territories of spirituality. Join us as we explore the wonders of our world and beyond, all while embracing the roles of curious bystanders rather than experts. Together we'll unravel the intricate tapestry of existence, blending the dichotomies of knowledge and wonder. Get ready to question, ponder, and delve into the dualities that shape our understanding of reality on Duality Check. I'm Drew.
And I'm Dean.
Welcome back for episode 10.
Dude, that's
We
so
made it
crazy.
to a decade.
Yeah.
Man, doesn't feel like it's...
10
I feel like
is
it's going pretty quick.
2.5 months of recording weekly. I mean, plus or minus like our preemptive recording and our week off last week. Drew being a little sick.
Yeah, you'll probably still hear a little bit of my voice here and there, but yeah, I was pretty much useless last week. Couldn't talk.
Yeah.
I stayed at home with the boys, and me and Rachel took some time just alternating days with the boys, basically. But yeah, we're back. My voice sounds better.
Yeah. And we're going to see if we can gain back our pre-recording lead. So we're going to try and like knock out 2 recordings this week. We'll see about that.
Yeah, we'll see. Based on the topics, and that might be the thing.
Yeah, we need to find one of the topics that I feel like comfortable to kind of riff on, and I don't feel that I need a bunch of pre-research just to have fun talking about it.
Mm-hmm. But, yeah, UFOs is always a good one. We could always fall back on UFOs.
Yeah, that's true.
Honestly, I think in the next day or so, you should look into the Chris Bledsoe stuff.
You've been saying that, and we've actually, who was it who wrote in that asked about it? It was Andrew?
A buddy of ours, and he was just
specifically asking what we thought of that.
Yeah.
And at the time, I hadn't ever really looked into him. I had been seeing his name pop up everywhere.
Right, me too.
But I hadn't taken in any of the material. So
my buddy sent that to us, and I was like, all right, I'm going to check it out, because I've definitely heard the name thrown around in the UFO community, in different videos and in different stuff that I was reading or listening to, like the Bledsoe name had been brought up. Just a sneak peek of what it's kind of or at least like what gives him just the basics is he's had, so back in 2007, I think, is when he had his initial UFO experience. Mm-hmm. And he was kind of at this place in life where he was really down, financially things were going bad. And so he's taking this fishing trip with a couple of employees of his and one of his sons. And they were at this place that they go a lot of the time. It's at this dead end street that kind of goes right to a little river lake, not a lake, but a little river that they like to fish at. And he, I was saying, he's at this kind of point in his life where he's really having struggles. And so instead of fishing, he just kind of lets the guys, he's kind of paying for the thing, it's kind of like a bonus for the guys because they're employees of his. And it's the end of the week, they just got paid and he's taking them out.
He's just trying to show them a good time.
Yeah, exactly. So he takes them out, gets them all in their truck, takes them out to this river. And he's like, all right, guys, I'll have fun. I'm just going to kind of wander. And he kind of wanders up and gets to this plateau field at the top of this little kind of ridge. And he sees these orbs. What he described as a 40-foot orb. So the entire orb was 40 foot wide. And he saw 3 of them, I think is what he said. And he just got super scared and didn't know what to do. So he kind of froze and was hiding, trying to hide in this tall brush. And anyways, he makes his way back down to the group, and they were scrambling. They're where you been? Where you been? By the time he got back, and his son was not there. It was just the other guys that were his employees.
Missing time.
And they are where you been, man? And he's what? I've only been gone for 15, 20 minutes, as far as he was concerned. That's what it felt like to him. Mm-hmm. And they were freaking out. And then they were he was where's my son? And his son had gone off to find him in a direction that he had initially gone off. The Chris Bledsoe guy, his son is Chris Jr., I believe, is the one that was with him. He's got multiple kids, but Chris Jr. was off looking for him. He went in the direction that he first saw his dad go off in, but he came back a different direction, I guess. And so he goes off to find his son, while the other two guys are like, I think he had initially told the guys like what he had experienced, like, dude, this is what I saw up there, and like I need to go find my son. And he was scared. Like, it was very scary to him. And then he ends up going down this road, like the dead end that I was talking about. They weren't at the end, but they were like halfway up this road or something. He goes off in that direction, and then he finds his son. Like, I don't know if he describes it as fetal position, but it kind of feels like it to me. The way he described it is like his son was like in this fetal position, like totally scared, like off into the brush. And apparently his son had also seen something, like an orb like thing coming at him, and he hid in this like brush that's like right on the edge of these woods to like hide away from it.
Yeah.
And and then by the time he gets to it, or his dad gets there, he's like really struggling like to like grasp what just happened. And eventually they get back, they get in the truck and they just take off. And then him and his son get back home, and his son is terrified. And I don't remember how old his son was. I don't know that he said it specifically in this video that I watched, but this is the interview that he did on Danny Jones' podcast that I listened to. And so his son was really struggling, and they get home and he's terrified, and he like goes inside and like turns on all the lights, locks all the doors, shuts all the blinds, like wants to be able to see everything, but doesn't want anything to be able to get in, kind of thing. And, basically from there, they deal with that night. And I think they end up going to like some field, some other things that transpire. They hear a noise out at their barn, like backside of their house or something. Their dogs are barking. So he goes to go investigate this. And then, basically that night is just them being fearful, and they end up getting back in their truck and going to the middle of this like field, wherever that might be. And then they just stayed there for the rest of the night because they didn't feel safe in their home, because I think he saw more orbs in the woods, like back behind his barn. He thought that somebody was breaking into his barn. That's what was causing the dogs to bark. So he went and investigated it. But in reality, the dogs were looking out into the woods, and he saw another orb. Yeah. That was kind of floating around doing its thing.
So what do you make of it so far yourself?
So it goes on a whole nother level from that. Like, the interview goes on, I don't want to get into it.
I know he goes into like consciousness and God,
spirituality and stuff,
and all that type of stuff.
Yeah. I mean, my take on it is
on just, I guess, the sighting itself and his like credibility as a witness.
His credibility does seem pretty good. I mean, so basically 5 years after this initial sighting, like for the next 5 years, the whole town is like a small town, and like it totally throws his life upside down, and his entire family talks about it openly, minus like his wife and like a couple of one of his sons, I think. I mean, I think it was actually Chris. Like, I think he was the one that struggled with it really a lot, because it was such a traumatic thing for him. But I think he's gotten better, is what they kind of described in the interviews. Like, he's been coached, but all in all, I think he's pretty credible. I do think that he saw something and he's experiencing something. Whether anybody else can experience it to the level he's experiencing, I don't think that's the case. I don't think that it's something that I can just go and have the exact same experience as him. Like, I don't think it's necessarily a physical...
based on what you're saying so far, it seems to fit the sort of classic MO of, the high strangeness being entangled with it.
Yep. Yeah, and it actually, like, it's going to have some similarities, and maybe I'll bring it up when we get to it, but like this idea of like panpsychism, and like the idea that like people and everybody's experience is different based on like their chemical makeup or their past or their history, and like, I don't know, it's fascinating stuff. And I mean I really do think that he's experiencing something, and like the spiritual nature of it is kind of hard to believe. Like the way some of the stuff he talks about is like, it's hard to believe, because it's just you can't experience it to the level. But he even like took Danny Jones out the night before their podcast to a beach where they saw orbs, and like supposedly now he's gained permission from the entities that are contained within these orbs to show people and to let them experience it as well. But they're not experiencing what he's experiencing. They're experiencing the orbs, specifically, like they're the UFO kind of aspect of it. But that's kind of just like not the base layer
consciousness
of it.
Interaction type.
Yeah, like they're not getting the messages that he's receiving. But also there was the History Channel was doing the Beyond the Skinwalker, and they brought him out to some wooded area. I don't know if it was on Skinwalker Ranch or not, but they hooked him up to a ECG machine, and it's kind of like a high-tech one now, like where they don't have to like shave his head and like put probes on it. They just have like a little makeshift, like a helmet thing with like, you know, they still have to like get it programmed to him basically. Yeah. And they do like baseline tests to make sure that what he is, what they're seeing is what's being, you know, they just did a baseline basically to find out what his brain looks like normally, and like when he's having a conversation, and like visually when things are stimulating him and stuff. And they basically said, go do your thing, go see the orbs, go point them out to us, like go lay out far enough to where you can't hear us what we're talking about when we're looking at these brain waves. And basically he looks up and just starts pointing. He's like, there's one. Like he doesn't say, they say just point. And they start seeing his brain light up, like visually. They start seeing his brain as if he's having a conversation, like as if he's receiving and communicating back to something. His brain is showing those waves, and all he's doing is like sitting out all by himself, not talking, just like pointing to the things he's seeing. And they do show up on camera. The orbs specifically, like you see the orb, but his brain is telling you that something more than just the visual aspect is happening. Like he's receiving some kind of signal, and he's responding to it as well. So it's definitely fascinating. And he's not like, he's obviously not, because obviously we haven't seen his stuff, so he can't be like somebody that's just like, oh, I'm like the ultimate UFO guy, and like everybody should like look at my, like he's not seeking that attention.
Yeah,
he's more like trying to get his message out. That's
kind of more of a sniff test I usually go for.
Yeah.
There's certain people in like the UFO culture who like seem to be like asking and trying to garner attention.
Right.
And trying to essentially like set the record straight for everyone as to like how things are.
Right.
He
doesn't seem to be doing that.
Followers and whatnot. And
he doesn't seem to be doing that. That
always gives me pause when I run into that sort of attitude or feel from someone.
And
Stephen Greer always gives me pause for that reason.
Same. Yeah. Stephen Greer.
But his message is actually in line with a lot of the sort of high strangeness stuff that I take more seriously about the phenomenon. It's just,
it could also be a personality thing, like
it's the way he goes about it. Yeah, some people are just more of that sort of self-promoter type of personality anyway, and it could be that case for him.
Yeah,
he also did a pretty huge service back in the day with his like disclosure project and all the
to get a lot of information
National Press Club interviews with all of the military personnel. Like that stuff is some pretty groundbreaking stuff back in the day.
Yeah, and I think maybe that stuff got to his head because people started giving him some sort of notoriety, right? So like there's a mixture
how
of
people
like
respond to notoriety and fame.
Like Chris is getting notoriety, and dude, he's like befriended some of the highest people, like CIA people. He's in, this is what usually would give me pause, like make me like look at it.
Pause.
But he also is like very, like he knows a lot of people, like, but he was never like a CIA asset, like as far as we know, like his whole life he's just been a contractor. He's been building homes, and then he has this experience, and then the people start coming to him and asking him questions once he tells his story. So like the people that like Hal Putoff is like a family friend of his. Like all of his kids know they went to like big events in their family, and like he was interviewing their entire family like separately, trying to really like find out whether they're telling the truth. And then once he got to the point where like they're all kind of telling the same story from their own point of view, and they don't have just this coagulated story that's been rehearsed, and then he just became a family friend, and he would visit them, and like he was going to there for Thanksgiving and stuff, like just became a part of the family. And there's other people that, we'll cover it because I think I want to watch the other episode with his son. Yeah. Ryan. His daughter was on the episode with him. Emily. She also was on the episode with Chris. The dad. Yeah. She was on the same episode on Danny Jones' podcast. But I also want to like read some of the old news stuff that came out like around the time that a lot of these stories are coming out, and like really dive into the story
on the whole case myself. So
you should definitely at least watch that interview and then maybe Ryan's interview. And but that's fascinating stuff. And honestly, I do think there is something there, whether it's as dramatic of like, because he gets into a lot of like he claims to, and his family and other people around him claim to have seen him heal people. So like, and there's a lot of like prophet stuff in there, like where he's been chosen to like tell the story and to like help humanity, like gain it, like going into this new age.
Oh, prophet, like prophetic, not prophet, like dollar bills.
Right. He's prophetic as far as like, these entities are using him to spread the message that this new age is coming of prosperity and peace. There's going to be, and he's, the story is basically that he's trying to let people know that, that we're going to go through some weird times and some hard times, which a lot of the stuff that I haven't read the articles, but I want to, it's like that he's talked about. These are some of the things that are happening nowadays, like in today's age, like these are some of these weird times, these hard times that going into the next era is going to change. So there's definitely some things that
I'll have to check it out for myself, because like once you start prophesying like hard times, weird times, like I need it to be a little more specific. Like if that is the extent,
that's what I want to read about too. I want to know
about, because you haven't checked it out.
I haven't checked it out either. Yeah.
If it's that nebulous, like it will be. Well, anyone can say that. Like it's pretty clear we live in strange times.
Right. You definitely want some more specific things. Otherwise, it's not really that credible. But yeah. So back to
but that also is like kind of like the first layer of like giving off that sense of like self-promotion, because once you start making predictions, people start going to you for information. Yeah. And that kind of like builds a community around you.
Yeah, and as far as I know, like he has
some people kind of become like professional UFO witnesses, where like they get interviews, they get books, they get talks at UFO seminars all over the country and the world, and they can make an income and a living just off of being a UFO witness.
Yeah.
So,
yeah, I mean, and those are the things, like he definitely has been invited to a lot of those things because of his story. Like he's been invited to a lot of these conferences. But it's hard. He's talked at some of them.
Just because you're involved in that stuff doesn't necessarily mean you're like a grifter or anything.
But when he also said like a lot of these things, like he, accepted to do a History Channel thing, but then it turned out that it was a waste. Like it was the opposite of what he wanted. Like they completely changed his words, and they completely gave it no context.
Right.
So like he stopped doing that kind of stuff, and like he is more doing interviews, like these 2-hour long interviews where you can see his face and you can watch him talk about the entire story, and like you can kind of come to your own conclusion.
Yeah.
Instead of just like snippets of it and like trying to like hone in on a specific.
And in general too, like I want to check out his story, but also in general, like I try not to rest anything on one case in particular, right. Because any one person you could be misjudging, True. Any one person could,
even the whole family, right? Like you could have
any one source, it's more about like the larger data, the trends, the big numbers that for me are what make me take pause and take it seriously, because you have to you have to come up with some way that like tons and tons of people are freaking like going insane,
right,
in a similar way, or that there's maybe something going on. I'm sure there's other options, but like, yeah, that gives that it's the numbers and the trends that give more credibility for me.
Yeah, the thing that gave me
one story that gets promoted too hard makes me skeptical.
Yeah,
whether it's Bob Lazar or the Virginia case, or
right. And this Bledsoe stuff seems like it's starting to become popular, but it's been
that's
so
also the nature of the topic
beginning.
Is that like something is going to be like the pop topic within the UFO thing at any given moment, just like everything in life, right? Like,
yeah, well, and especially if they go on like a lecture or like a circuit, right? Like they decide they're ready to talk, so then they go on 5 different podcasts or do 5 different interviews on, like it seems like
someone
it's like
convinces them
into
to
your head.
share their story,
right.
Right.
Even though like this started in 2007, and it's not like right away he was just, I am the prophet and I know all these things and they've told me these things. Like it was like this really long drawn out thing. And even over the years, like even as far as late as like 2010, 2011, he was back to the point of like, I'm done with this stuff. Like, stop contacting me and I'm done. You're ruining my family. My kids are being bullied. And like, he was I'm done. And then they came to him again, and it was a lady that he talked to that came to him. It was an orb that once this orb got to him, he describes it as this orb, a entity coming out of the orb and the orb staying within the entity while they're there in his presence. And it came to him as a bowl at first, and then he turned and like moved, and then there was this lady, and he talks about it a lot in there too. But so those are like symbols that are kind of biblical in a sense, or astrological or whatever. And she gives him this message of, why this is happening. What we are asking of you. This is your burden to bear and like your message. And then he changes his mind and it continues. Like, and these are like times in his life where, I don't know, it's hard. It's really hard to like judge it just from the one interview. Like I really want to go back and like read it all from the beginning almost as much as we can. But like there's major UFO people from the beginning, like Hal Puthoff, like from the beginning is like a central focus of that. And then there's, I don't know all the names that I have to re-listen, but there's like major people that like UFO investigators from different MUFON groups and different groups from all over the world that came and like interviewed his whole family and like, and then eventually didn't find anything that made them uncredible. And, and then there were CIA people but then the whole UFO group was telling him not to trust the government people because they'll just kill you,
or they'll just
like that's what they were saying at the time. But they were scaring him and his family because he was trying to find a group of people that could understand what he was going through, right? And then those are people but the government was coming. Like there's no stopping them. They're going to get to you eventually, right? So it's fascinating stuff. It really is, and it definitely got my thoughts going as far as like what the UFOs are and what, in this interdimensionality of them. And like, we'll even talk about like a little bit of like, we're going to learn about new dimensions today and what they might manifest and like how that might be. And like hearing his story of how they manifest and like how they start as orbs that move around in however they want. And then they manifest in like a physical form, but not physical in the sense of like me and you, more of like a symbol.
Yeah.
It's interesting. Very interesting. But maybe we should, before we go to break, introduce I'm actually excited for that episode. Cool. I'm excited for that episode because I want to dive into it and find out more because it really is like just the way they talk about it.
We should do it.
Him personally, watching him and listening to him is very fascinating because he's not the flashy, like, I want to tell everybody my story. He's like super introverted and like you could tell he's like getting emotional just speaking. And like his daughter talks about how like after all these encounters, like he learned that there's a panpsychist view, like they have this panpsychist view of the universe where every single living thing has a consciousness.
Yeah.
And and don't have any right to kill anything. So now he's like, since that point when he was learned that lesson, that anything that dies, he was a devout hunter, like he was a big hunter, and now he can't even kill, bugs, and like he cries when, he weeps and gets really emotional when like he sees things die. And real quick, there is this story, and this is just really cool. They have a video, and they showed it on the podcast of their tree in their backyard. They call it the burning tree, and it just randomly, actually multiple times, randomly started burning from the inside out. And this was during one of their encounters, like just started spontaneously combusting from the inside. You could see the tree just glowing, and then like once the tree kind of breaks open, you see the fire come out of it. It's crazy. They have a video of it.
Huh. Okay.
Yeah, there's some crazy, and like even like Danny Jones, he saw the orbs that they were talking about. Like like you really got to get everybody on board, or like have some kind of hypnotic thing to really get people like massively like experiencing these things with you.
Okay.
Anyway,
well, I'll check them out for sure.
Definitely check it out.
All right. Well, since we're actually pretty close to a break here, let me before we do that, we did actually have one communication. So my buddy Mars, his brother, whose name I don't have,
Jupiter,
is a scientist, and he's been listening to our show because Mars has been telling him to.
What kind of science does he do?
According to Mars, something with organic molecules, or I was like, is he like a biologist or something? He's like, it's something like that. So I'm going to read some of these texts. Okay. If you are the one we're reading the text from, please email us.
Yeah, if you don't want us to use your name, that's fine, but we want to know your name.
Yeah, but I would like to know like what you do for a living as well.
Yes.
Anyway, so this is going to be kind of broken up. This is like Mars and his conversation with his brother about our podcast.
And then he's like sending you messages from his brother about our podcast?
Yeah. I was like, can you send me those? And so like this is kind of weirdly broken up because at a certain like when you talk with someone over text, like you'll be talking about something and then all of a sudden you're talking about something else, and then you're back talking about one thing. So it's kind of broken up because of that.
All right.
Anyway, he says, I'm listening to their first podcast episode as I'm working. It's cracking me up to hear their perspective of what science is. So essentially, a scientist performing science is listening to a podcast explaining science. I like the irony. From listening to the first episode, your friends don't understand science publication and how research and science is conducted. The least political and most unbiased funding of science endeavors today is probably the Catholic Church, then industry, then private groups, then self-funding, then academia, and then at the very bottom is government funding.
Sure.
So, I mean,
maybe nowadays.
I would like to talk to him about that or pick his brain on that because I find that fascinating.
Yeah, if that's his view on like if the Catholic Church funding is the least or is the most unbiased.
It's the least strings attached, the least like politically like motivated, like the least
have less of a
biased. Yeah.
Yeah. Okay.
Is the way he says it here. Least political, least biased.
Interesting.
Which honestly,
that's not too far off what we were saying.
Makes sense to a degree because, like, the modern Catholic Church, the reason I don't remember that exact moment in the first episode where we're sort of accusing the Catholic Church.
That was more of like a historical thing.
We were talking about I think historically, the Catholic Church had a lot to gain from pushing science and the story in one way or the other. In today's society, I don't think the modern Catholic Church necessarily has much to gain from doing that. They can only lose reputation and trust.
Yeah, and I don't know that we specifically talked about the modern Catholic Church though either.
Biased science in one way or the other. Yeah. And I've only actually heard good things about the Catholic Church and their endeavors in science. Mm-hmm. That they're pretty open-minded about, the way the world works.
Well, yeah, they've accepted UFOs and like right? Haven't they accepted UFOs?
I don't know.
They've said,
but
I don't know the quote, but I remember
they're open to like modern cosmology's explanations for the source of the universe, because for them, like, God is still the prime mover.
Sure.
And he set this clockwork magical universe into being. So for them, funding science is like learning God's process of creation. Right.
Or at least how it unfolded.
Regardless of what it tells you.
Yeah, because it's still not going to tell you what the initial like spark of it all was.
But the interesting point, and I think is where we agree, is academic and government funding being the
most biased.
On that other end of the spectrum, being the more biased and more politically attached.
Yeah, I mean, I feel like, other than the Catholic Church, and I think we still are pretty much on par with that, is I do think that industry is probably one of the least biased, but
it depends on the industry and
what the science is.
So exactly. For instance, like there's notorious examples like the sugar industry with funding things about nutrition and diet. There's obviously the pharmaceutical industry, and there's the cigarette companies, the tobacco companies. There has been like some pretty major examples of particular industries funding science in their own way. But that doesn't cover it's also not necessarily fair to like blanket saying industry funding science.
Yeah, that's true.
Right? Like
that's true.
It's examples.
That's true.
He goes on to say, by the way, your friend's podcast episode on economics was surprising to me. I didn't expect to talk on the Austrian school and them to have a libertarian economic perspective. It was simple enough for regular folks to grasp too, which was nice. So
Sweet.
Thanks for that.
Yeah, that's good to know.
He says, I'm trying to get through your boys cast episode about secret societies, but I've been out of California too long. It's been years since I had a drum circle. I like that. And then their conversation kind of breaks off into, from what you're seeing here, they breaks off in like weird, like conspiratorial stuff. He talks about some podcast guy who's like just discovering that like lead has effects on radio waves, and is like talking about how they used to paint the rooms in lead and how that has effects on cell phone signals. And anyway, it was like really weird conspiracy thinking about like 5G and lead paint and all that stuff. And anyway, I hope he doesn't lump us in too much with that guy, because I don't
know anything about that.
There's all sorts of ways. I do know. Oh man, there are people. I've seen people online who will like sell you quote unquote safe 5G routers, or like ways to like modify your home Wi-Fi to make it safe. And they basically sell you a Faraday cage to put your home router in, which essentially just makes your router not work.
I was going to say, doesn't it just block all the signals?
Blocks all the microwaves. So if you're worried about the microwaves affecting your body, you can put your router in something like that, or you can put it in a box and paint it in lead, and it'll block the signal.
Yeah, or
but
just
also won't work.
Just get an outdoor router and put it on your roof. If they make them, if you're worried about it.
Not to say that some people who are conspiracy minded about routers, there is something that I have never gotten to the bottom of with 5G, and specifically the frequencies of microwaves that are being used. Some of them are specifically resonant with water molecules, and which can cause like weird heating and weird effects in the human body. But that's typically only if you're exposed to a super high level, like if you were an operator working on a tower right in front of it while it's powered on.
But not necessarily in smaller doses.
Right. So
I mean, I'll tell you, my 5G signal phone will burn a hole in my genes if it's, like it gets hot.
Oh yeah.
Well, I don't know if
typically
that's
the processor on your phone that's getting
like
hot.
you could feel like internally, like like your leg will start like it's like you start having like a weird feeling in your leg if like it's in your pocket for a long time.
If you're doing like heavy uploads or downloads, maybe
that's what it was. I don't know, but I remember having like specifically, and I can almost still feel like a weird.
Either way, like so like for instance, like in cooking, you have options in cooking. If you want to cook something, like you have the option to like go high heat for a short amount of time, and you have the option to go like really low heat for a very long extended amount of time, and both are valid approaches for getting something cooked to a temperature.
Right.
So in theory, that sort of thing should sort of apply.
Oh, I see what you're saying.
In the same way to like radiation exposure, but I know like at
depending on how long you're exposed to it.
Yeah, but like I would think you would have to like reach a certain level in order for it to register at all.
There would still have to be some threshold.
Anyway, it's something I'm ignorant of, and I don't actually have big conspiracy theories about. So
yeah, I haven't looked into it deeply. Yeah, he keeps going on like.
Yeah, this was the lead thing.
I saw a video on the Driftless area, a place in Midwest which never had glaciers. It's an area I already like visiting, but now I definitely want to go this summer.
Yeah, which is cool. Like,
the Driftless area.
Yeah, that's an area where the glaciers didn't come down, which would be interesting geologically.
To see the difference, what the area looks like without having had glaciers ever crush it, push it down.
This is back talking about the lead stuff. Anyway, we told him we would read this, so
yeah, please keep it coming.
Reach out,
if you're hearing this, please let us know.
And then he sends me this. I don't know why he sends me this.
Mars.
Mars. It's a picture of Smurfette, and it's X-rated. Oh my god.
All right. Well, do you want to introduce it? Should we just introduce it when we come back?
Yeah, let's just, I guess, well, I mean, you guys already know what the topic is. You're reading it on your players. So we'll actually start talking about it once we come back from break here.
Yep. All right.
So
we'll be back.
We'll be back in a few. And
enjoy cobwebs.
Enjoy. Welcome back.
We are here. We are ready. So, as you guys see from the title.
Yeah, well, first off, no beer review this week.
Oh, yeah. Yeah, that's true.
I don't know if it'll be this way going forward, but for me at least, I just started keto.
Yeah, and me, it was just last week I was sick. So, and I had a few beers the last few days, and I was like,
yeah,
I don't need them.
So maybe Drew might be doing some solo beer reviews in the future. I'm going to be on keto for quite a while, so it'll be a while before I'm drinking again.
Yeah, maybe on Thursday I'll I'll grab myself a little tall boy or something. And
But I'm officially in ketosis already. I did
that was only one day too.
Yeah. Well, they say like once you've done it before, because this isn't my first time doing it. Once you've done it before, like your body kind of like gains the skill of using the ketogenic state. It's that first time you really try and do ketosis that can take you a while. Sometimes it takes people like a couple weeks to achieve it for the first time.
Yeah, I definitely want to start that. It's just hard with boys doing the meal prep and stuff.
Yeah. Well, I don't do any meal prep.
Yeah.
Yeah. But
I would need to.
Yeah. Like I said, the first time is harder.
Yeah,
like you have to be ready to feed yourself at any moment because like you're not used to dealing with the cravings. So a little bit of meal prep, or at least the type of snack food that'll work.
Yeah.
For me, because I've done it before, like I'm pretty used to like intermittent fasting and like only eating like lunch and dinner or only dinner. So I can just like not eat till I get home usually.
It's not like a conscious thing, but I do kind of intermittent fast in a sense of like I don't ever eat breakfast, and I usually don't. I usually don't have my lunch until about 1, and then I stop eating around. I guess it depends 9.
On if you're having something that to your body is counted as fasting. So like for instance, like I used to drink a lot of energy drinks, and that's always a big problem for me putting on weight. So like if you wake up and like part of your morning routine is like an energy drink, like that will break your fast because of the sugar.
That's true. Yeah,
but
that's true.
If you wake up and just have like black coffee, that won't necessarily.
Yeah, I've been mostly drinking. I mean, I had gone on a stint of like drinking those organic rock stars, like where it's not really organic, obviously, but it's like cane sugar and green tea for energy instead of like guarana and all the other crap that they put in other energy drinks. And lately I've just been on like V8s, the V8 energy drinks, which is just green tea energy mixed with fruits and veggies and sugar, obviously.
Yeah.
But yeah, no, that's true. I guess it's not necessarily a fast if I have those in the morning.
Yeah. So I'm going hardcore, guys. I'm keto. I'm not drinking alcohol. I'm not smoking weed, and I'm stopping vaping, which I had a huge vaping problem. My nicotine levels must have been through the roof. And yesterday was my first day, and boy, when I got home from work, I was like, my head was spinning. Yeah. I was like, not good,
feeling pretty out of it.
Yeah, right? I ended up cheating and having one of my roommates just one cigarette, and that actually helped my mind to like that spinning head feeling to go away. And today I've had no cravings, no spinning head feeling, and my blood sugar is more regulated today, which is good.
That is good. Yeah, we don't need you passing out.
Yeah. Anyway, the topic for today is called Einstein's intuition. And
I know you've been excited about this one.
Yeah, so this is something I came across a long time ago, maybe in like 2013-ish.
Okay, so not too long after he first posted the videos and came out with his book.
Yeah, like it was a little bit old when I first encountered it, but it was pretty new.
Wasn't it like 2010 or something that he published his book, or was it earlier than that?
That's a good question.
Did you read the book initially? Was that your first introduction to it?
My first introduction was the Vimeo videos.
Oh, those are
which I'll post on the show notes.
Vimeo, man.
So there's a part 1 and a part 2. So all right, so let's back up. It's this dude named Thad Roberts, who is a very interesting character. But he came up with this sort of like alternate theory of everything. Maybe if you could call it a theory of everything. Probably
it's like almost like a different quantum,
it's almost like a
theory,
different understanding of gravity, and it does combine quantum stuff with gravity in certain ways. So in certain ways, it's kind of a theory of everything.
I guess basically once you hear it all, it does sound like a theory of everything. Well, it's definitely a theory of everything that we don't know.
Sure.
Kind of, right?
Yeah, like in his later stuff, he starts going into like how you can generate all like nature's constants and stuff based on his model, which definitely pushes it more into theory of everything territory.
Right.
But once he gets into that level, the math goes above my head and I can't like follow along. So I can't really comment on that part of it. But ever since I saw it back then, it gave me a new tool for thinking about how gravity may work. And it has sort of forever shifted my thinking. And I have yet to hear, so any other scientists out there who are hearing this, and if you want to comment, I would love to hear more about it. Yeah. But I have yet to hear any physicist or anyone comment on this who doesn't believe this theory, who actually has taken it any sort of seriously, and then comment on the sort of general idea.
Yeah,
I've heard people say, "Oh, well, his math's not there, and so it's not a real theory." But that's like on his YouTube video comments, and that's not on the videos where he actually does the math. So I don't know that that's a fair critique, anyway.
Well, a lot of at least the videos that you sent me that I watched, like it's more of a way of visualizing it. It doesn't really go into the math at all.
Yeah,
like, it's a way of like conceptualizing the ideas.
Yeah, so the way he sort of starts out is he sort of takes you through some of the limitations with modern science's understanding of gravity, some of the blind spots in modern science, which is some of the stuff we talked about in episode 1.
Yeah.
So he talks about what are some of the mysteries, and he says, like quantum tunneling is a really weird one, where like an electron can like essentially escape a boundary that you put it in. He talks about dark matter. He talks about dark energy.
Yeah. That's the one I have the most confusion about.
Dark energy.
Yeah.
Yeah.
And his theory, and like his theory.
And how his applies to it. Yeah. I've got a decent grip on how his theory applies to that. What else? Well, I guess gravity itself, like a sort of intuitive understanding of what causes gravity, what is gravity. There's still like weird mysteries surrounding that. Depending on like what scientists you like listen to or hear from or read in today's like society of like science communication towards the public, you'll either get the interpretation that gravity is the bending of space-time,
right?
And in which case you will see this image here. Look at your podcast player, which is like a flat 2D plane bent down like a ball sitting on it, being stretched like a trampoline.
Yeah, it's like that video that it's gone around where it's literally a bowling ball on a piece of fabric that bends it downward.
Or like you may have even seen like a physics teacher give you that demonstration in person with like a trampoline and like a bowling ball and a golf ball. Yeah,
rolling it around and showing the curvature and like how things move.
The problem with that's one formulation that you'll hear. And then you'll hear this other formulation, like on the quantum side, where they're like, you'll hear them saying like trying to quantize gravity.
Yeah.
And you'll hear them saying things like looking for a theoretical like gravitron.
Right. It's this theoretical particle that like,
what does that mean?
It's supposed to be the force of
gravity is supposed to be just a distortion of space-time, then what does it mean for it to be a particle? Like, how do those two ideas coexist? Or are those two ideas that are in conflict? And because like modern physics is like so fragmented into all of these theories and no one is like 100% sure like which direction is the right one. Yeah. Like, as a layman, it can become really confusing to like take on these ideas and like learn about them. But anyway,
so how does that come back to his?
So the way it comes back to his theory is he tries to, with that 2D plane,
that slice of space that they take when they do that example.
The idea of that is like they're showing you how gravity can bend, but the problem with that is you're taking essentially a 2D plane, so you slice through the entire universe and you give one 2D plane slice, and then you take a piece of mass, that always happens to be a 3D piece of mass.
I was going to say, yeah.
You place it on top of your 2D thing.
Yeah.
And that 2D thing starts to bend in the third dimension.
Right. But they don't have a label for that.
But what is that third dimension?
Yeah. Because they don't label it, right?
Right. So once you switch that metaphor back to 3D space, if you try and visualize it in 3D, like, how can you be bending the 3D space? Like, through what?
Yeah. In what direction? In what? Yeah. What's that axis that it's bending in?
Right.
Yeah.
So how do you do a 3D
model of it?
Trampoline sort of model.
I would love to see one.
I've seen stuff like this. Here, I'll pull up 3D space-time curvature. So you'll see things like this, where they're like sort of like distortion fields, sort of like that.
So it's all being pulled in around it,
right?
Into it. Like a black hole.
It's almost like contracting of 3D space. So like for people who aren't looking, well, if you just look at your player, but if you're not looking at all, the visual or the verbal would be like, take a 3D wire mesh cube, and like that is your grid of 3D space.
Right.
And then like you're sort of like stretching, like almost as if something on the inside is sucking in that grid.
Yeah. So basically, I'll try to explain it. It's the cube itself is a grid-like structure, but then on the center of it, there's a mass, right? It's the mass that's causing the gravity. And then in the cube, each side of that cube that we're trying to describe is concaved towards the mass.
Right.
So instead of it being flat on each side of this box, it's concave towards the mass.
Right. So that's a similar way of showing it to the 2D plane, but it's more of like a 3D-ized way of doing it. But even that sort of like has limitations. Like, it's hard to, Anyway, so let's go back to Thad Roberts and his Einstein's intuition. It's called quantum space, QST is what he calls it. I think he calls it quantum space theory.
I was going to say, just looking at this image, it's hard to look at that image and intuitively see how curvature and how things would move in the way that they are described by science, right?
Yeah, I mean,
initially,
I
just
can
by looking at that,
sort of see it, but yeah. All right, so essentially, here's what Thad is proposing. He's proposing that, so he'll do this metaphor. What if I asked you I gave you a chunk of gold and I set it in front of you and I asked you to keep chopping it in half? How long could you do that for?
Yeah, you could only do it until there's a single atom of gold.
Right. So you can keep chopping and chopping and chopping, and at some point you're left with one single atom of gold.
Yep.
Okay. Now, can you chop that in half? Sure.
Yeah.
But if you chop that in half, is what's left gold anymore?
Right.
And the answer to that is no. Like, if you chop a gold atom in half, so you're splitting the protons and neutrons.
Yeah, based on the idea of what
you're going to end up with, two different atoms, smaller atoms, but they're not going to be gold anymore.
Right, because the makeup of them is the gold. It's
right.
Not
so you've sort of transcended the definition of gold, right? So in a way, you could say that atomic materials like gold are quantized because there is a minimum unit mass, like a minimum unit that makes up a thing. So there is a least amount of gold possible, which is a single gold atom.
Right. There's a minimum configuration of it.
Right.
Yeah.
And so in quantum theory, there are minimums there as well. Okay. So if we were to do that same thought experiment we just did for gold, but we were to do it for space itself. Okay. And we're say, like, take the space inside this box and then throw away half of it and zoom in.
Chop.
Throw away half of it and zoom in. Throw away half and zoom in.
Yeah, just keep doing that.
Over and over and over. At like 10 to the minus 30 something times of doing that, like incredibly small, you will get to a point that's called the Planck length, where at which point you can no longer divide space and still be talking about space. Whatever you have at that point, it isn't necessarily space anymore.
Because the Planck is the minimum you can
The
divide.
minimum Planck length is the minimum amount of length possible. The minimum amount of space.
Okay.
There's Planck energy, and there's like all these different Planck constants.
And these are the minimums of all of those different constants, right?
Yeah.
The Planck
This is why quantum physics is called quantum, because everything is quantized. They've discovered that at the smallest scale, there are certain like discrete chunks where values like snap. There's no smooth motion between certain values at a certain level. Everything is quantized, hence quantum physics.
Gotcha. So you're not seeing these obviously anymore. They're just chopped to the smallest possible.
Right. And like a Planck length of space is so small that like I think the way he puts it in his thing, whether or not he's right about it, but the way he put it is like, if you were to take a hydrogen atom and blow it up to the size of the solar system, then a Planck length would be smaller than a hydrogen atom in that solar system.
That's right. Yeah, he did say that.
Yeah, which is crazy small.
Wow.
So we're talking like minute, tiny little units and things.
Yeah.
But okay, so what he proposes, and here will be a visual, is that once you get down to that level, is that what if those little quantum bits, that minimum amount of space is like actually a thing?
Right.
Is like a little ball or bead of space.
Yeah, he calls it
a unit. He calls it a Planck.
Yeah.
Or a quanta is what he calls it. He calls it one quanta of space. And so what he proposes is that what we know as our 3D space is comprised of a bunch of these quanta of space kind of floating and moving around.
Yeah, it's these little tiny balls or bubbles of the Planck, like the tiniest, the Planck basically, right?
Right.
Or is that the Planck chopped up? Or
No,
it's basically the Planck, right?
Is the little quanta, the Planck.
So the Planck is like a little quanta, and he describes it as spherical, though, right?
I mean,
at least in his theory, in his visualization,
like we would have to do some crazy physics,
obviously, to even find out
stuff. Like, light doesn't
Planck
even mean anything down on that scale. So, like, how could you measure it? So,
right.
I don't know. It's all theoretical. What shape it would be?
Right. Actually, not that it matters, but as far as like the dynamics of it, it could matter.
Sure, it probably would matter.
Yeah.
So whether it's a ball, whether it's a little cube, whether it's like a little torsion field or a little like
cigar-shaped thing, yeah.
Anyway, so you have these quanta floating around, and so he gives the analogy of like, if I wanted to, let's say I got something small, an electron, okay, and I'm going to go hide it somewhere, and I want you to find it. Mm-hmm. And I just say it's 100 miles west from here.
Yeah.
Is that enough information for you to find it?
No.
Because I'm only giving you one dimension.
Right.
Of position. So then if I say it's this amount west and it's this amount north, is that enough information?
No.
Because it could still be up or down.
Mm-hmm. Yeah.
So then I say it's at this altitude.
Yeah.
And it's still not enough information for you to find it.
Not an electron, no.
Because you also need to know like when it's there.
Yeah, right.
Right? So
that's
space
the
is 4-dimensional.
That's the dimension we would be missing, yeah.
Right. So we have 3 spatial dimensions and 1 time dimension. So if I don't give you those 4 coordinates, then you can't hope to find the thing that I hid. Mm-hmm. Right? So in the same way, like if I were to give you those coordinates, essentially what it would be doing is it would be counting the number of quanta west, the number of quanta north, the number of quanta up or down, and then like at what point in time. Right. So like that could essentially be the address of like that little bead, that little quanta that electron resides at.
Right.
Okay.
But it goes deeper, right?
But it goes deeper. So like how can you visualize more dimensions than that? Well, if you visualize it like this photo here of these balls floating in space, then what is this space that they are floating in?
Yeah.
If the balls are space, then what is it that they're floating around in? And so he proposes the term like that is like a sort of super space.
That's right.
It is like the space that the quanta of space float in. And so you get essentially another 3 dimensions of space there.
Right. So the super space has 3 dimensions, height or width.
The quanta
length.
themselves have 3 dimensions. So I can count quanta over, up, down.
Mm-hmm.
And
to get to there, and then once you
get there, the quanta themselves could move their position with respect to each other.
Right. So that's there's 3 dimensions within that. You use 3 dimensions to get to that space, right? And then you use the other 3 dimensions to find out where within that space
where that quanta is. In regards to the other quanta
in this super space.
But then there's 3 more dimensions you can do, which is within that quanta, where are you? So you could be within the quanta, you could be like forward or back or out on the surface or deep on the inside.
Because if we're thinking of like in this example where we're thinking of as like a sphere, you could be at the core, you could be at the the edge, you could be somewhere in between that.
Right.
So that is another 3 dimensions.
That's another 3 dimensions. So now you have 9 spatial dimensions.
Is that interdimension or? So it's interspace or whatever they call it.
You have the quanta themselves and like counting left, right, and center.
Yeah,
that's your traditional 3 dimensions.
Yeah.
Then you zoom up a quanta, and your position within the quanta requires another 3 dimensions.
Yeah,
and then the quanta movement in relative to each other through superspace requires another 3 dimensions.
So what is it? So there's superspace, there's space, there's superspace, and then
there's like I guess I forget the term he uses for it. It's like intra-space, something like that.
And that's like the space within the quanta itself.
Yeah.
So there's space to get you to the area the quanta could be, and then there's the superspace to find out where in that space the quanta is. And then there's the intra-space to find out where within the quanta.
Where within the quanta you are.
That thing is whatever, theoretically or hypothetically we're looking for.
Mm-hmm. And so
that's 3, 6, 9 dimensions.
That's 9 space dimensions. And then what he says for time, he claims there's 2 time dimensions. He says that essentially the quanta themselves like resonate, and so every resonation of a quanta is like what we call time.
Okay.
And then he says,
that
if you look at quanta within the superspace, you would need time to describe movement of quanta through superspace. So if this quanta and that quanta are right next to each other and they switch positions, you can only move across time. So in order to describe movement through a superspace, they would also have to have time through a superspace. I don't know particularly for my dumb mind why that couldn't just be the only time, but
and why is that distinguished between that and what our time is, right?
Right. And probably because what our time is all confined within 3D space time.
So our time is a derivative of what's going on
and that time of
level.
Describing the quantum movement through superspace is outside of 3D space-time because it's describing the movement of 3D space-time itself.
Because we know that we know how time affects us based on like our molecules, just like what's the word that I'm looking for, are degenerating, so that it's like our molecules having all of this energy depleted, and we know that because it's depleting there is like this idea. You're talking
about
time.
Like radioactive decay?
No, I'm just thinking of like why we know that time is a dimension, like how we actually interface with time, and how we know like over time your body is going to decay.
Yeah, well, we know time is a dimension because for the example earlier, if I need you to find something, if I don't tell you when to look, you won't, like the position in time has everything to do with whether or not you'll find it, just like the position in space.
No, I understand that.
So
but
like
I'm just
the definition of a dimension is like, what is a way a dimension would be described as like a thing that you can move within without moving through something else, right? So if we have like a 2D plane here that's X and Y, I can move through X, change my X coordinate without affecting my Y coordinate.
Right.
And I can change my X coordinate if we add a third dimension without changing my Z coordinate. So
is that
that's
same for
what
time,
makes
though?
X a dimension, is that I can move within X while staying still in Y and Z. And I can move within X without necessarily moving through time, or I can move through time without necessarily moving through space. I can stay at the XYZ point and just be moving through space.
But is it the same way for time itself? Like, can time be described as the same dimensionally as the other descriptors of positioning? Like,
yeah, like if you stay absolutely still, which is a big question whether that's even possible.
Right.
But let's say you could, if you keep rooted in XYZ point on a grid and just stay still, then you're moving through time, but you're not moving through space. So in a way, like it's its own independent descriptor.
Then like the idea of like moving as fast as the speed of light and time not moving, like that's where things get weird.
Right. So that's where you get into
like I'm just trying to
special relativity.
Yeah, like I'm just trying to like the description, the actual like understanding of like the description of time itself, and like how it interfaces with
time is a struggle to try to explain what it is and how it is, and calling it a dimension, it's sort of a special case of a dimension.
That's what I'm
because it only moves in one direction. You can't like choose your position on it.
That's
arbitrarily, like you can with space.
Exactly.
But
so it still has the similar,
is part of the
attributes.
Same fabric of space-time, because and we know this because of all of Einstein's contributions. Like we see space-time distortion, otherwise like we have to account for space-time distortions and relativistic effects in order for GPS to work.
Yeah, and that's
like
at the macro.
Right now, there are satellites orbiting the planet so fast that it's still really slow compared to like relativistic speed of light scales. But like we're talking tens of thousands of miles an hour. These satellites are orbiting.
But as far as timing goes,
and because of their relative speed compared to ours, they experience time dilation that we don't. And if we don't account for that, then over time, their clocks get off from our clocks, and therefore our GPS stops working. Mm-hmm. Because you need GPS to have accurate clocks, or else you won't be able to get your position from a satellite. So
I mean, I guess it's just
we know that time dilation and space dilation is a thing, at
least at the macro scale, right?
Right, because and that's like where like all the quantum physicists and stuff, like that's why they're trying to quote unquote quantize space, because once they zoom into that level, I mean, basically all the effects sort of disappear.
Right.
And so we're over a little bit, so let's take a break, and then let's dive back in and like flesh out what are some of the implications of thinking about time and space in this sort of way.
Yeah, I was gonna say
that's where it gets really interesting for me.
Definitely go more into like his idea of like the dimensions of time.
Yeah, I mean, he's basically saying that time is the resonation of a quanta. It's like a quanta pulsing.
And so like that extrapolating up to what we are, like
is that
those resonations, once they get like you have the tiny little space, and once you get particles within that space and they resonate and they hit each other more and they interact more, time affects them differently because they're interacting more, right? So like the quanta are interacting more when the mass is bringing them closer together, or is it less? I don't know. We'll keep talking about it.
Yeah.
Because in his idea,
dude, it's weird stuff, and there's so many like cool alternate like gravitation and like space-time theories. And I sort of discovered that this is like you would essentially classify it within like a whole class of these sort of theories.
Okay.
And we'll get to that in a sec. Welcome back.
We are back. Again, for all you people who only tune in for our beer reviews, I apologize.
Yeah. We ended up spending like half an hour talking about the new Avatar: The Last Airbender Netflix show. That's as we're recording this, gonna be coming out in 2 days.
Yep. Which we're super.
We were both huge fans of the original animated show.
Yeah, we loved it.
Oh man, just the nervous energy of like, is this Netflix adaptation going to be good? Are they going to totally flop it?
Yeah, they've.
I don't think they're going to flop it. They're not going to M. Night Shyamalan it. But.
No, I really hope
can
not.
they finagle good acting quality out of their child actors?
Right.
Can they tell a story? Are they going to be like authentic to it? Is it going to have the heart?
The casting is good. Yeah, it's more about like the acting and like keeping you in, like as far as like the world is like, and a lot of the snippets I've seen, like the world, like seeing the world in live action is exciting. Like seeing the places, seeing. I like
that they're going like almost like hyper realistic, like so it's like almost more real than real. So it's like fantasy.
Yeah.
So it kind of like gives them an excuse for things to not look totally perfect, like
or not totally real.
Showing like Appa and Momo, these creatures, these mythical creatures that aren't real life, like. It did it like it's good enough that like I can work with it, you know, even though it doesn't look totally real, and it makes it better because the environments and everything are a little
bit more fantastic. Yeah, exactly. Yeah. I'm excited to see the Water Kingdom.
Yeah.
That'll be a fun one.
Man, I'm so... All right. So next episode, well, maybe not next episode if we record this week.
Oh, What do you want to do next episode? What are you talking
I don't know. We're recording on a Tuesday right now. We won't be watching the show till the weekend. But if we're going to record on Thursday, then you'll have to wait till our next episode to see what we think of the show.
Yeah, and if you're fans of the Avatar, Last Airbender, and obviously the animated show is very popular now. Like now, it's kind of like grown even more than what it was originally. I don't think
since they released it on Netflix a few years back.
Yeah, I didn't watch it on TV when it first came out, like episode to episode.
I caught some episodes.
Our nephew was into it because our nephew was into it, but I watched it when it came out.
Like, unless you had like a TiVo box that like recorded TV,
right.
Like you had to actually sit there at the
time,
air date and time to catch like a full serial thing, and not miss something.
Exactly.
And that was really rare for me to do as a kid. So it wasn't until like I could watch it
once it came out
like DVR or
once it came out
rental,
on
I forget when
I think the first thing I watched it on, not the first thing, but but I really went in like a chronological order and like watched the whole thing outright was Netflix when it first came out.
Yeah, I think for me, I may have downloaded it. I've been a long proponent of picking up digital goods that fall off the information highway trucks, as it were.
Yeah, maybe that was when I first really watched it. Scene by scene is just
because I used to keep a little catalog. If you remember back at our old house, I used to keep like a catalog of like movies and stuff that we could stream from our OG Xbox.
Yep.
Or something. It was like a media player.
Because I watched it.
I think that's the first time I saw it.
And
I watched it with Chris back then. He and I watched it together for the first time. I remember
that must have been when I first started watching it. Then, but I loved it when I first started watching it.
I think so. Chris, tell me if I'm wrong, but that's what I remember.
When I first started watching it, I just fell in love with it. Yeah, like the whole background and stories.
For those of you who haven't watched it, and you're like, "Isn't that a kids show?"
It's much more than that.
Yes, but the best kid show you've ever seen, and
that's a lot of philosophical things.
It's very philosophical. They talk about very deep topics. It's very adult for a kid show.
Yeah,
I mean,
at least
they cover everything from freaking genocide to
sexism,
war and sexism and family struggles, and it's really good stuff, man. Epic storytelling. It's fantastic. So if you haven't watched it, watch the cartoon first, or maybe watch the Netflix thing. But if the Netflix thing sucks, go back and watch the cartoon. It's worth it.
It's better. It's much better. Well, I don't know yet.
I don't know yet if it's better.
Yeah, I don't know if you
probably. But
I think it's a great groundwork, whether or not you like the Netflix. I think you should still, even if you like the Netflix, go back and watch the cartoon.
We'll just say I rate it, and I'm not alone in rating it amongst, like, for me personally, it's not just amongst the best animated things I've ever seen. It's amongst like the best TV I've ever seen.
Yep.
So
agreed.
And it's a little slow start in the first season. So if you're like, oh, this is a kid's show, but I'll give it a try because they said, you're gonna have to get through the first season before you see what we're talking about. Well, at least a good halfway in, then you'll see what we're talking about. Yeah,
and once you're into it, and I'm sure other people who like it attest, Korra was also really good. The Legend of Korra.
Yeah, it's hit or miss really for me. I like certain aspects, but it's not the same.
No, it's definitely not the same. But it's good as far as like continuing to build the world and like see what happens after and stuff. But
anyway, later on, M. Night Shyamalan got assigned making a feature film, which is an unfair assignment, by the way. Yeah, trying to take an entire season of this show and make it into one movie, but
nothing against him necessarily. I mean, he did what he could with it. I just don't think he was the right director for it.
He was a terrible director for it, and he made a lot of unforced errors.
Yeah, and obviously he made the movie he was going to make, but
I don't think anyone could have done it great, but he put his own brand of badness on it, and it killed the Avatar franchise for like over a decade.
Yep, and all we had to fall back on was the show, was the animated show.
That's all the nervous energy we're working on for when this drops.
Yeah, we're gonna binge it for our nephew's birthday.
Yeah, he's like, what do you want to do for your birthday? He wants to spend the whole day hanging out with the family, binge watching the new Avatar series. So that's our plan for this weekend. I'm excited for it. It's gonna be fun.
All right, we'll get back into it now for people who are like, shut the hell up.
Yeah. Einstein's intuition. Okay, so we kind of laid the great groundwork, right?
Yeah, I wanted to get back into like
the groundwork was like the visualization stuff of the like dots of quanta, and those dots of quanta floating in a sort of super space.
Soup.
Yeah.
Or space.
I see what you did. Cool. So how is this useful?
Yes. And I want to talk about the time dimensions again, like a little bit, like in his definitions of these time dimensions.
So in our reality, okay, like in our everyday experience, like our everyday experience is 3-dimensional. Okay?
Yeah.
We know that we need time. We know that time is a thing.
Yeah.
Because when you describe the world, it's incomplete unless you can describe it in motion.
Mm-hmm. Or having having time to describe a certain aspect of it.
There is no complete description of the world unless you account for the fact that things move and things change.
Yeah.
Right?
Yeah.
And so what is it that defines the difference between the way something used to be and the way it is now? And that is time.
Okay. Yeah.
So in a similar way, if you have a bunch of quanta floating around in a super space, if it is possible for those quanta to move in regards to each other, then there needs to be an aspect of time in that conception of space.
Right.
Which is outside of our 3D space.
Because quanta are still matter, right? It's still matter.
Well, no, it's space.
Well, it's space, but it's still a thing.
Right.
In this idea. It's a thing.
It's an empty quanta of space, or maybe it's a contained quanta of space that is part of a particle or whatever, but yeah, it's a thing.
And so these quanta are interacting.
Right. They may be moving around, they may be bouncing around.
So that is one aspect of this time. That is one dimension of the time. But the second one is the resonation, right? It's the quanta itself bouncing or moving or resonating.
Or for me, I think of it vibrating. Like maybe it's vibrating, maybe it's colliding. Like whatever it is. And the reason it's important that you have the ability for those quanta to like resonate or vibrate is because any proper theory of everything has to account for special relativity, where based on your velocity and motion, your experience of time can be different than everyone else's.
Right.
So you have to have a way to have an individual experience of time.
Okay.
There is no universal clock in our
universe.
Our universe, according to Einstein.
Everybody is on.
It is impossible to have everyone set their clock and put them in sync, and they will never stay in sync.
Right. Okay. Yeah.
So
there's our 11 dimensions then.
There's our
that he talks
11 about. Dimensions that he talks about.
So we've got the 3 space dimensions, we've got the 3 super space dimensions, and we've got the 3 inner space dimensions.
Right.
Okay.
And then we got
the 2 time dimensions.
Right.
So the time dimensions, again, just for myself, are the movement of the quanta in relation to each other within super space, and then the quanta themselves vibrating or whatever they're doing to resonate, and that is another, because it is the movement. It's the movement of it. Right. Got it. Okay.
So what is any of this good for? Other than like a clever way to like visualize more dimensions than 3, which is also pretty cool.
Yeah. So it is very hard. Like it's very mind bending just thinking about those 11 dimensions and like just as they are and what it might mean. Yeah.
Yeah.
But then how do they?
One of the big mysteries in quantum physics.
Yeah. What's the mysteries
is,
that they help?
Like for instance, quantum tunneling.
Mm-hmm.
Okay. So you can imagine how that you can solve quantum tunneling with this. So imagine like an electron is attached to a quanta And then imagine that quanta swaps space. Like that quanta and the next few ones, like it moves
within super space.
If it moves within super space in regard to the other quanta, all of a sudden that electron has tunneled.
Right, because
all of a sudden it's in a new coordinate address, even though it stayed on its quanta.
So it didn't change the dimension of being on the quanta. It changed the dimension of being
where that quanta was with
in
regard
relation
to the others. And so you can see where something very small, like an electron, that only maybe has a handful of quanta it's attached to, those actually can rearrange themselves with regards to other quanta at that scale and end up with effects like tunneling.
Because I know in his videos he talks about like how to describe the length between, like if you take this quanta on this end and this quanta on this end and you connect those 2 points,
right,
and what is the number that is generated as how much space that is between those quanta,
right,
and it changes, it fluctuates,
right,
based on, because these things are moving, and like the idea.
So we use like human level measurement units of like meters and feet and yards, but if we were going to be accurate to physics, like in actuality, it should be like a Planck. Mm-hmm. You know, we should be counting.
It should be 20,000 Planck
whole
or whatever.
Integer multiples of Plancks.
Right, right.
So the definition of a meter should be a whole integer multiple of the Planck length. And so in that way, if you zoom in to where you see these quanta floating around, if you want to describe the position of anything, like you could, as they're moving about their space, I'll put like this image up, as they're moving through their space, like you can kind of count from one quanta to the next. And you can see how as they move, that same sort of line from one quanta to the other, there may be more or less of the quanta in between. And so at any given moment, it may blip from 5 quanta away, 7 quanta away, 10 quanta away, 4 quanta away. And so when only you go at that really small scale.
Right. Once you
when
go
you
up,
zoom out enough, there's
averages.
So many billions of them that it averages out to where it's not noticeable.
Right. And then you just get the one number.
And that's why you don't get like people quantum tunneling through walls, but electrons can.
Yet.
Unless, if you can figure out the technology for moving the quanta.
We're getting there.
Maybe
working
that's
on
what the UFOs are doing.
Exactly. And that was kind of my connection to that Chris Bledsoe stuff. Is like this idea that, like, you know, if panpsychism is a real thing, right? If let's have an exercise on this, like if the idea that every molecule, every living thing, every organism is conscious, and it has the ability to take advantage because it knows, like it has some knowledge that, or like the coagulation. So like if we were to get to a point where we understand that every single cell in our body is conscious and we can tap into that, and we know that our consciousness is our consciousness that we experience is a accumulation of all the consciousnesses within us. And instead of it being like a physical electronical technology, it's more of an internal thing where you can tap into this in like quantum space, like the quantum leaping from like using that internal technology and understanding of like your consciousness, and how your consciousness is not just attached to this, but you could move within the space. Like we're describing the super space. Like it's an interesting thought exercise, and like especially if you get to a point where you're not an embodied thing, right? You're more of like a spiritual or ethereal like idea, but you're still conscious because you have these, or you're still made up of particles that interact with each other on this quantum level, and you can go from being coagulating them together to make appear as a being, but then you can shrink back down and then move or you're a higher dimensional thing. So
that's sort of like a panpsychism that is like combinatorial. So it's like, it's that every big consciousness is sort of an amalgamation of the small.
Yeah.
In a similar way to like macro scale things are an amalgamation of smaller atoms.
Yeah.
Right. Interesting. Okay.
It's an interesting way. It's just a thought exercise going on in my head right now.
I don't know how to
Based
attach
on those
it to
two
this
ideas.
topic per se. Like,
Well,
I
I'm just
see
thinking
where
of the
you see
ideas
similarities,
of-
but I don't. Yeah.
I'm not attaching to it in some solid way. I'm just playing with the idea of panpsychism and how that could relate to this quantum level of being able to move through space, or like the individual particles, or not particles, but the individual particles, being able to take advantage of the Planck and knowing, how to move around and whatever. Just a thought.
Interesting. Yeah, I mean, there could be a whole reality down at that scale
within
aware of.
Yeah.
It would follow all sorts of different rules.
Yeah, and it wouldn't be a physical reality either. It would be
it would be almost like, it would be semi-physical. It would be like what our physical reality is built upon, but
right. But it wouldn't be what we describe as physical, like as
almost like
matter.
metaphysical.
Yeah,
but
right,
kind of physical.
Physical in the sense that it's a thing, but not physical in the sense of it's all of these smaller things attached to each other to create what we are. It's not a bunch of cells and organisms that come together, but it is, if you detach it enough, still that.
So,
crazy to think about.
Let's go on to another one of the mysteries that he proposes to solve here. So he proposes to have like that this way of looking at things explains dark energy. That's a big one. So let me rephrase, sort of in a layman's term, the mystery of dark energy.
Please, this is the one that confuses me.
So dark energy is the phenomenon that you see when you look out in the universe at any galaxy and you see that its light has been shifted towards the red.
Right. Yeah, I understand our understanding of dark energy, but his understanding.
No, yeah. So, well, for listeners.
Yeah.
So people who don't understand, like if you look out in every single direction, you look one way and you see some faraway galaxies, they're shifted towards the red. And the farther away the galaxy, the more shifted towards the red. In fact, that's our definition for how far a galaxy is essentially how far red shifted it is. Okay. And if you look one way, and same thing if you look the other way, same thing if you look up, same thing if you look down, any direction you look, everything is shifted red. And so the explanation for that is expansion.
Right. Everything's moving away from
the entire universe is expanding, and because it's expanding, the light waves traveling to us through an expanding universe are causing those light waves over time to stretch out.
Yeah.
Hence shifting towards the red. Okay. But what this proposes is a different mechanism for that. Okay.
Right. Instead of it needing to be moving away, it's a different thing that causes the red shift.
It's a different thing. It's not the distance that's causing it. So here's the analogy. Okay. Let's say I'm standing outside and a car goes driving by. I'm going to hear a Doppler effect, right?
Yeah.
I'm going to hear, right?
Mm-hmm.
So it's blue shifting as it's approaching me.
Yeah.
And as it's moving away, it's red shifting.
Right.
Okay. That's a standard example. But did you know that you can also get a red shifting of sound by dropping atmospheric pressure? So let's say I put you in a big long tunnel. Okay.
Yeah.
And someone honks a horn a mile down that tunnel at you. Okay. And as that sound is coming towards you, if we had the ability to control the atmospheric pressure inside that tunnel and drop the pressure, it will also drop the frequency of the horn as it reaches your ears.
Even if it's not moving.
Well, it's moving from the car that honked to you.
No, I know, but the car itself is not.
The car
moving.
is perfectly still. Yeah. It's sitting there.
Right.
And it just honks. And you hear a normal honk. Right. But if it honks and in the process of it traveling down that tunnel towards you, the pressure drops, you will hear a lower pitch honk.
As if it was moving towards.
As if it was moving away.
Okay, so it's right.
It
so
would
it's the
be
red shift.
A quote unquote red shift.
Gotcha.
So moving towards a lower frequency.
Yeah, and then if the pressure changed in the opposite direction, it would create a blue shift in a sense, right? Acting as if it was, it would sound as if it was coming towards you.
If it were to honk its horn in low pressure, and then you were to raise the pressure as it traveled towards you, it would shift the other way.
So that's the So that's the explanation that
right. So the explanation for these quanta is that they have different, because they're sort of floating around in a superfluid, the super space, they can be more and less dense. Okay. And so the idea is that as you get close into the black hole, a supermassive black hole at the center of a galaxy, that there's the quanta themselves are super dense together in that super space. And then as that light travels out, or as you move out from that, that the quanta get less and less dense. Mm-hmm. And there's another sort of implication of this, which is that anytime you're dealing with like particles and density, you're dealing with also phase changes. And so we understand that that water can be a solid, a liquid, and a gas. And what is the difference between them? It's the difference between how packed together those particles are.
Right, the configuration of the molecules.
Right. So
manifest into different states of the same particle.
So like a black hole in this analogy would essentially be like a solid of space. Ooh. It's like the solid phase of space where it's packed so tightly together that the quanta can't resonate freely anymore, and therefore there's no time. And because they're so packed tightly together, you can never escape once you go in. And so you would get a similar like event horizon sort of aspect to them.
We haven't talked much about the gravity aspect of these things of it yet.
Right. So then as you move out from that black hole, you would get into the quote unquote liquid phase, right?
Yeah. And
then essentially what he's proposing as the explanation for dark energy is that once you get outside of a galaxy, then you essentially go into another phase change, which is...
I thought this is how he describes quote unquote dark matter.
He does, yeah, but this too is that as you get further and further from the galaxy, you get out deeper in space, and it's essentially a new phase of matter. Right, it's like cooler. The gaseous or plasma phase, and where everything's cooler. Yeah. Everything's further apart. Yeah. Much more room because of that change in temperature, that change in density, that's causing the energy of the light that's traveling to you to shift towards the red. Yeah. It's losing energy.
So so that definitely helps me with the dark energy. Yeah, I think the phase shift is what he was talking about with the dark matter. Like as far as
that's
like
what he's talking about too with the dark matter. Right?
Yeah, it's like the phase shifting of it is like the same we would expect in air, like in our physical space. Right.
Right. So to recap on dark matter, that's the mystery of like when you look at a spiral galaxy. Mm-hmm. And you look at the stars out at the edge of the galaxy, they are rotating around that galaxy too fast.
At the edges, yeah.
At the edges of the galaxy, those stars are rotating too fast around the galactic center. You would expect it to be slower based on the equations of gravitational equations of relativity of Einstein.
Right.
And Newton. Anyway, there's not enough gravity to explain how fast they move, and so the difference between how much gravity there needs to be and how much gravity there actually is what we call dark matter.
Right. And it's just they say that there has to be a matter out there, and invisible, so they call it
we
dark.
know it's there because we know its gravitational effects are there.
Yeah. But we can't see it.
But we can't see it. We can't interact with it.
Yeah.
There's been
No
decades
light
of
is affected by it.
Dark matter particle detectors here on Earth built deep underground, and none of them have come up with any dark matter.
So it says
that's like
so that
with the theory that dark matter is actually a particle that only interacts with normal matter gravitationally, but not electromagnetically or chemically.
So that's the mystery, and then this theory that Thad
it uses the phase change is that as you get out to that outer rim of the galaxy, that extra speed of the rotation of the galaxy or of the stars is due to the quanta going essentially from the liquid to the gas phase, and so there being less resistance and less quote unquote space for them to travel through to keep up with the inner stars.
Right. Wow.
And
we kind of touched on gravity a bit, but we didn't go into
we should talk about gravity itself.
Yeah, gravity in its effect on the theory. I'm just gonna turn that off real quick.
The babies are budging a little. So gravity. So essentially with this model, we're talking about like gradients, right? We're talking about, instead of like curved space-time like a trampoline, we're talking about gradients of quanta being more and less stuffed together.
Right.
Okay.
More and less dense.
And so the 9.8 meters per second squared of gravity that we experience here on average on the surface of the Earth would be because of us traveling around the sun through a gradient of quanta.
Right.
And because there's a gradient, so here's how he explains it. What is the definition of a straight line? Okay. So if you want to move in a straight line, you first have to define what a straight line is. Okay. And so one way he proposes to define that, which I think is a pretty valid explanation, is like, let's say you have your left arm and your right arm straight out ahead. Okay. And then you move forward. To know that you're moving in a straight line, you would have to know that your left went forward the same amount of space as your right did.
Right.
Because if your left went forward more than your right did, you would start curving.
You'd start turning, yeah.
Right?
And this, yeah.
So, and this is also how, like, you'll see, like, science documentaries and stuff that talk about space-time and relativity. They'll talk about, like, a geodesic. Anyway, we can get into all that later. Anyway, so the definition of space-time being, or of moving in a straight line being, your left and your right go in the same amount of space.
Right, interacting with the same amount of space at the same time.
Right.
Which means you're going
if you're
straight.
going through flat space-time,
yeah,
then,
that holds up.
And if we're using this quantum model,
yeah,
then you would essentially need your left hand to hit the same amount of quanta as your right hand did in order for you to go in a straight line. But now if you're moving through curved space-time where there's more quanta on your left side and less quanta on your right side, then I will hit less quanta with my left hand than I will with my right hand, and a straight line to hitting this quote unquote hitting the same number of quanta with each hand will take me on a curved path.
Right. So that's where you get the curve, the orbit basically around a massive object, right?
Right. Which is not so different from like Einstein's explanation. He's just explaining these. He's saying that these bodies are moving in a straight line through curved space.
Right. It's not them turning or moving or being acted on by some force of gravity.
We're not being pulled down to the ground by gravity. Right. We are moving through curved space-time in such a way that we are intersecting with the ground
on
at 9.8 meters per second squared.
Right. So
which
yeah,
we
so an
feel as a
object,
force because we're being pressed into it.
right? So like if you were to think of like a spaceship trying to leave the atmosphere and go onto an orbital path of the Earth, like the left, whatever side that's pointing towards the Earth is being pulled more, is interacting with more matter or more mass. So it's the arc of it looks like an orbit. It looks like it's turning, but in reality it's still moving straight. It's just interacting with the particles in such a way on its right or left side that makes it look like a turn, but it's still moving straight. Right.
As long as you're not firing a rocket, as long as you're not accelerating, then you're moving straight.
Yeah. So I'm just thinking of like in this theory, like it's if something is moving in an orbit and
yeah, an orbit's a little different because like to get a rocket into orbit,
I'm not saying like a perfect orbit, but if you're interacting with anything, so if you're flying by,
if you're looking at the launch, they are not moving in a straight line because they're firing their rocket.
Right. I don't mean the line. I mean like so let's just say an object moving through space, and it interacts and it's going into this gravitational, quote unquote gravitational force of another object. It looks as if it's moving in an orbit around it,
right?
But in reality, in elliptical,
in reality, it's moving in a straight line through curved space,
right? So it's just interacting more
and
or
in
less.
Instead of it being quote unquote curved, it's like through a space density gradient,
right? If
space is a bunch of quantas, then instead of it being how you would traditionally think of curved space, it's more that it's a space density gradient would be the way to think about it. So moving in a straight line through space that has density gradients means you will take what appears to be a curved path.
Right. Even though it's still straight to the object itself.
Right.
Like you're not turning a wheel to move left or right. You are moving straight in the same path you were before. It's just you're moving in what looks like a curve. It's just
what crazy. I struggle with this theory is I still don't see a fundamental explanation for why why matter curves space in the first place.
I was gonna
and to me that's one of the biggest mysteries of like our physics.
What gives it the characteristics of interacting the way that it does?
Like physicists, they just take it as a given, like, matter curves space, and space. What do they say? Like, matter tells space how to curve, and space tells matter how to move, or something like that. Anyway, they both influence each other, and they're very highly connected, like space and matter. But like, I don't understand why that's the case. Like, why is it the case that the existence of matter is a curvature of space-time?
Yeah, even in this theory, like it still doesn't answer that question.
Because it doesn't.
Like, why does
this
matter,
theory, as far as I've seen him explain it, doesn't explain what matter is within this model, right?
And why it interacts with things the way it does. Yeah.
Yeah. So it definitely leaves,
but it definitely answers some mysteries. Yeah, but it definitely answers some of the mysteries, right? So even like the quantum, the viewer effect, right? Doesn't it answer some of the questions of like the light being a particle and a wave at the same time?
I don't remember his explanation.
He doesn't necessarily answer it specifically, but you can derive some of it being able to be a particle and a wave at the same time is due to the fact that it's actually quanta.
Oh, that it would be. I can kind of construct that intuitively. Yeah. So like, if light is a particle and a wave at the same time, it would be because, like, let's say you've got some sort of packet of energy that is traveling quanta to quanta to quanta to quanta.
Right.
And as it's causing them to vibrate at each other, they're like putting out waves as well, based on the vibrations that the light is causing on the quanta.
So what we see when we are viewing it is the particle.
And in fact, maybe that's the definition of light, is like quanta vibrating in a certain way.
Or, yeah, light hitting a certain packet of denser and less dense quanta.
Yeah.
Which causes ripples. So that would, yeah, that's another whole nother thing that he doesn't even get into, really. But he does mention the idea. I don't specifically if he just describes why it acts that way or why it interacts as a particle and a wave. But
yeah, for me, a satisfactory theory would tell you why is it that space and time are so interlinked the way they are.
Yeah.
Oh, the other thing that I realized in researching for this episode and going back through and like kind of figuring out like what is like of this, like if you consider this like a sort of theory of everything, and I recommend if you are more on the like mathy, sciencey side, go check out his like deeper stuff or his book where he like lays out the quote unquote equations that designate this theory. But essentially this is an ether theory. This is like bringing back ether. And I didn't realize for a long time that was essentially what they were talking about with like an ether. And Einstein did away with it in his formulation.
Talked about it.
Yeah, well, he originally was using an ether until to
describe
it was a popular thing in physics, and Einstein sort of did away with it in his discoveries, but a lot of people have been trying to bring it back in, and so there's like a whole like family of like new theories that essentially propose an ether again, and some of them try to avoid that term. In fact, most of them do. So like quantum fluid dynamics and whatnot. So
it's kind of the same idea, like this idea of like the
idea that
fluid.
Space is a fluid.
Right. That's kind of this idea of it being this moving and interacting fluid that as things move through it, it interacts differently because of the density, the changes in density, the changes in pressure over the vastness of the universe, because we know it's billions and billions of years old. So the light interacting and the light that we are seeing is being red shifted or blue shifted. Not blue shifted, really. Everything seems to be red shifted. But yeah, so it's all like interacting in this soup of quanta that is dynamically changing based on the densities.
Do you recall the other series I had you watching a little bit of, the Dialect YouTube channel?
No, I can't pull it from memory. No.
So if you guys haven't seen this channel, I'll link it.
This is where they do
it's another version of this, but to me it's a little more thought through, which it takes into account the movement of the space a lot more. So like you can think of you standing on this earth as a force pulling you down at 9.8 meters per second squared, or you can think of the earth exploding outward at all times, and that space is coming down through you at 9.8 meters per second squared, keeping everything at that same size and shape. And so it's not that you are being pulled down, it's that you are actually traveling up through space at 9.8 meters per second squared, but that is the speed at which space is coming down through you. And so you appear to be stationary as long as you stand on.
Yeah, that kind of breaks down to me when like you think of like a spherical object though moving through space, because it's not unless you're moving.
No, that's where it highlights it for me.
Yeah, but like if you're thinking about a thing moving a single direction, would it not have a different effect on something on the opposite side of the earth?
It would. So, well, no, because everything in the earth would be pulling in. Like space would be pulling into the earth at all angles proportionally.
Oh, gotcha. So everything's being pulled in.
So think of the earth as like a waterfall for space.
So it's not moving necessarily through. like the way we think of moving through something.
Mm-hmm. Like space is moving through us.
Right.
Coming from up and going down in all directions.
Right.
So,
okay.
like, it proposes like a sort of like a waterfall theory of space, where space is some sort of fluid, kind of like
where does it go once
Einstein's
it gets in there?
Intuition by Thad.
That's what I want to know. Where does it go once it gets into the
Yeah,
earth?
so I thought that was a really interesting question, and then I ran into another guy who also had a third, like, sort of like quantum fluid ether theory.
Yeah.
And this is just, dude, this guy is awesome. He's like freaking, I'm going to link it.
Yeah.
He's like he's this old dude with this tiny little YouTube channel. He's got like 30 views on every video. He's like barely got any subscribers. I think I was like his 5th or 6th subscriber. I somehow found his videos like in researching this.
But he
sits there and he like proposes out his whole theory of everything, and it's also an ether-based sort of thing, like space being a fluid that moves through you type thing. And so the way he explains it is that like special relativity still exists. So what's happening is that as space is moving into you, like into the Earth faster and faster and faster, it's also getting more and more and more and more and more dense. And it's moving faster and faster, which is getting closer and closer to relativistic speed, which is distorting space-time, which essentially makes every like piece of mass like a little bit of a black hole.
I was going to say, wouldn't it, like, yes, the Earth is the most massive thing near us, but wouldn't it also, like, we are also mass?
Right.
Would space also be coming into us individually, and also all the other massive things individually? So that,
see, for me, what I'm looking for, like, I want a theory that explains like the mass or like the space sucking in, contributing the energy that allows mass to keep massing, you know? Because I feel like mass just existing should be constantly burning energy. Like, it should be constantly burning energy for like electrons to orbit a proton and neutron, and for the protons and neutrons to like vibrate and like maintain their shape and their structure. Like, that should cost energy.
Well, that's what time
like,
is
over time.
Yeah, that's what time is.
Where are they getting the energy to stay stable?
Reproduction.
And I've never heard anyone like explain that on the quantum scale. Like, where do quantum effects get their energy to keep maintaining themselves? Because it seems like little perpetual motion machines, the way scientists describe the stuff. Oh, it's just an electron orbiting. Like, okay, but
wouldn't
like,
it have to decay at some point? Yeah.
Yeah. Well, and they do decay, but like,
but over a massive amount of time.
But there's a lot of like vibrations. There's a lot of movement. There's a lot of like fluctuating of stuff.
Interactions like, between.
Yeah. So like, where is the energy source for all that?
Yeah, it's the ether. It's
just the temperature of the universe is like the distance away from the Big Bang. And as
or it's the dark energy
further into entropy, further away from the Big Bang, further into things cooling down and spreading out.
Yeah, eventually
everything will lose its energy and won't be able to maintain itself into mass anymore.
And that's when we contract again into a single point, and the Big Bang starts over.
That's when dark energy turns negative and everything sucks inward.
Everything sucks inward, and then you get the reproduction of the Big Bang event.
Whoa!
Massive die-off, and then a massive regrowing, massive all at the same time, because they think like they expect the Big Bang theory, or the Big Bang happened faster than the speed of light. So imagine that happening in reverse at the speed of light, or more than faster than the speed of light. It would just be an instantaneous like re-snapping or reconfiguration of the universe. That's fascinating. What was the channel? What was that small channel? You got to send me that.
Yeah, I'm looking for him right now. Dude, he's great. He reminds me of like Mr. Rogers or something.
Really?
It's so great.
That's so, I mean, all of this stuff is just so fun to think about. to like play little games. Honestly, and like, that's what I do with this panpsychism.
Physics
and like,
is one of those
stuff,
things. Yeah,
putting it all together and like figuring out what it might look like if you interacted these different ideas together. Is this it?
Where are you?
Oh, Veritasium, is that the one?
No. Veritasium's legit.
Too legit.
Too legit to quit.
Now I'm unlegit.
I'm gonna have to search. You'll have to get the link the same
and
as
for that
everyone else.
reason, I must quit.
Anyway,
so who knows that reference? Dude, come on, somebody knows it.
Is that? I love physics, but I'm really partial to like fluid space theories. Like ever since I heard the Einstein's intuition idea,
I like it.
I find issues with his specific formulation of it, but the more I run into other people giving their formulations that are similar, the more I think like
there's something to it.
I feel like the answer, because all of those family of theories of everything have in common is that dark matter and dark energy are an illusion. Like they are a fallout of the world working this way, and it is not actually true that 95% of the universe is unknown to us.
Right, it's actually just a part of what we know, but it's just outside of.
It's just the effect, the
of
repercussion of the universe working by these laws of physics.
Yeah, so you just got to change the parameters we're putting on this. I love this stuff.
So
yeah, we're coming down to the end here, but appreciate y'all listening
as we wrap.
Appreciate y'all listening. You can find us on YouTube, Rumble, Apple Podcasts. What is
Hugh Mannfield.
Hugh Mannfield.
Fluid space theory.
All right, we'll link that too in the
Look at this guy.
description. Okay.
Look at this guy. Oh my god.
He's like a Mr. Rogers meets a hello. Oh yeah.
I'll play a little bit of that. I don't think Reason or our recording software records the YouTube videos I play, but I just played a little bit for Drew. So
we should
edit
get that
a little bit in.
We should get that to record.
Dude, I want to hit this guy up because look how small. Like he's got 32 subscribers. He's got 85 views on his first video here. So I'm going to link to all you guys. Give this guy some love, but I'm going to try to reach out to him like, yo, would you come on our podcast? I really want to talk about your theory of everything.
Yeah, that'd be fun. I bet
he really spent a lot of work like putting this all together. Look at this. He's got
oh my god.
He's got 10-part series, 11-part series describing his fluid space theory. Then he's got proving Einstein wrong, how the cosmos really works. I haven't finished them all, but
and he's still posting it. 2 months ago was his last video.
Yeah, no, he's still active. So I want to hit this guy up. I want to talk to him.
Yeah, no, that'd be awesome.
Yeah, this isn't like 15-year-old videos. No,
yeah, that's what I was expecting.
This is within the last year.
That's what I was expecting, was something that's like.
But he hasn't gotten enough love yet, so
we'll give him some love.
Let's all give Hugh Mannfield a
man with two N's.
Yeah, he's wearing a little scientist outfit.
He's got the
lab coat. He's standing behind the periodic in front of the periodic table.
And he's got a receding hairline with white hair.
But he wrote a book too. He's got a book, and at the beginning of every episode, he's like, and you can check this out in my book, which half of it is a science fiction story in case you're not into the math. So you can get my ideas through that. And the back half is an appendix with all the math.
Oh, sick.
He's a little bit cocky, but like in a humble way, because when you like listen to him, you're like, man, this is like a nerd. But look at this description of himself. I have achieved a complete and superior understanding of gravitation. At the moment, I understand gravitation better than anyone on the planet. How can I say that? because my method predicts all the same things GR predicts, but also the dark matter effect as part of gravity field of normal matter. This has led me into a profound insight into the very nature of matter and to the unknown difference between matter and antimatter. A difference that profoundly changes their behavior. While I did this work to satisfy my own curiosity, I feel an obligation to share it. I don't believe I would have been given this gift only to keep it to myself.
Yeah. Braggy but humble.
Right? So anyway,
I'm definitely going to watch all of those.
Mannfield.
So yeah, we're going to wrap up here. We got, you can find us on YouTube, Rumble, anywhere you get your podcast, Apple, Overcast.
Yeah.
Any of those.
Shoot us an email, hosts@dualitycheck.net. Let us know your favorite theory of everything.
Yeah, check us out on our
Tell
website
us if
is the
you've
same,
seen Avatar: The Last Airbender, and if you also think it's one of the greatest TV shows ever made.
And if you hate it, we'll read your email, but you're wrong. But yeah, hit us up on Facebook, Instagram, DMs, anything like that. If you know us and you're, one of our friends, shoot us a text if you like our stuff, or if you wanna,
you can help us out with a review.
Shoot us any videos or anything like that.
If you listen to us on Apple Podcasts or search us on Apple Podcasts, you can actually leave a review for the podcast there. If you listen on Spotify, so the reviews are either on Apple Podcasts, or if you listen on Spotify, you can review each episode that you listen to. After you're done, it'll ask you, how did you like this episode? And you can give it a star rating and a review.
How was your experience with this episode?
Right. So please engage in those ways. That'll help us get ranked up in their algorithms and help more ears hear this channel.
Yep.
So we can get more ears on Hugh Mannfield's channel.
Yeah. And we wanna interact with you guys. So please, just email us if you have any kind of stories or if you have personal experiences with any stuff. Like we dive into a lot of different esoteric stuff and UFOs, and if you've heard our episodes on secret history of the world and a lot of the esoteric history stuff, there's a lot of stuff out there. Or if you are a scientist who finds it funny listening to a couple podcasters talk about science and disrespect your field, so let us blatantly know. We want to read your emails to everybody. Knock us down a peg. Yeah, for sure. All right, go. Later.
Adios.